Oh my goodness, you guys. It's that time again. We have 2.5 minutes until things get started. Hope you're all doing well. Oh, I gotta click that button so that people don't show up and think there are ads that are keeping them from watching. There we go. Button clicked. Hope you're all having a good night. It's a Monday, so long day of work behind us. I was out there watching the Warriors, who are presently losing to the Pacers, but the game is pretty close in the late third quarter, so there's some hope yet. Perhaps Melanie will come out and, or I guess come in and tell us what's happening there. Hope you all are doing well. Oh, I'm excited to do Advent of Code tonight. Just want to spend a little bit of time coding a little bit of stuff, and then we'll be good. I'm still struggling to see what the picture is going to be on the left there, but I have faith that it will turn out to be something great. There's that. Let's do this. Okay, and let's check our sound levels real quick. Oh yeah, beautiful. Totally great. I mean, perhaps a little bit quiet, but nothing we're going to complain about, that's for sure. 1 minute and 26 seconds. Continue to march our way closer and closer to where we're going. It's been interesting. I got 5 subscribers, which is a lot for a channel that I basically have been putting very little in. Oh, let's go ahead and commit the skeleton while we're sitting here. Skeleton for day 6. Commit and push. Didn't push anyways. Push. Yeah, let's go ahead and delete these. We don't need that. Should probably get some kind of linter, but alas, we do not have one. This all seems fine. What unversioned files? There we go. What changes are there? Commit all this stuff. I don't care. Gosh. Okay, there we go. And just in time, 30 seconds left. Let's change the tab with the music on it. And I'm going to try and do a better job of doing searches for code reference and stuff on this screen. I keep checking on the other screen, and that must be a little bit frustrating to watch. Though I'm a little bit wary of like what comes back in the Google results. But I trust that the people on Twitch will be fine. And on YouTube, I can just edit it out. So I'll try to do a little bit better. We'll see whether or not I remember to do that in the heat of the moment. Gotta turn down the sound in my head. You guys should be hearing the same amount, but less in my noggin. And let's go. Day 6. Tuning trouble. The preparations are finally complete. You and the elves leave camp on foot and begin to make your way towards the Star Fruit Grove. As you move through the dense undergrowth, one of the elves gives you a handheld device. He says that it has many fancy features, but the most important one to set up right now is the communication system. However, because he's heard you have significant experience dealing with signal-based systems, he's convinced the other elves that it would be okay to give you their one malfunctioning device. Surely you'll have no problem fixing it. As if inspired by comedic timing, the device emits a few colorful sparks. To be able to communicate with the elves, the device needs to lock onto their signal. The signal is a series of seemingly random characters that the device receives one at a time. To fix the communication system, you need to add a subroutine to the device that detects the start of packet marker in the data stream. In the protocol being used by the elves, the start of packet is indicated by a sequence of 4 characters that are all different. The device will send you a subroutine. Will send your subroutine to a data stream buffer, your puzzle input. Your subroutine needs to identify the first position where the 4 most recently received characters were all different. Specifically, it needs to report the number of characters from the beginning of the buffer to the end of the first such 4 character mark. For example, suppose you receive the following data stream buffer. After the first 3 characters have been received, there haven't been enough characters received yet to find the marker. The first time a marker could occur is after the 4th character is received, making the most recent 4 characters MJQJ. Because J is repeated, this isn't a marker. The first time a marker appears is after the 7th character arrives. Once it does, the last 4 characters received are JPQM, which are all different. In this case, your subroutine should report the value 7, because the first start of packet marker is complete after 7 characters are processed. Here are a few more examples. This is after 5 for VWBJ, after character 6, after character 10, after character 11. So 1, 2, 3, 4, 5. So we just want to count the number of characters that we've been processing. How many characters need to be processed for the first start of packet marker is detected? Okay, let's check our puzzle input here and delete yesterday's. Let's put that in the data. And then we want, actually don't even need while Skinner has next line. String input stream equals Skinner dot next line. So we basically want to see, are the previous 4 characters all different? So I'm trying to, like, we could maybe use like a set for this or something. We probably don't even need to. It's only 4 characters. So let's, okay, 4 int I equals 3. I is less than input stream dot length plus plus I. If, and let's just check the 4 characters. So input stream dot caret I minus 3. Yeah, how do we want them all to be different. So how do we check that they're all, like, what's a good Boolean for this? Okay, we can just do the naive thing. It actually doesn't matter. Input stream dot, let's grab them. Character A equals this, and then we're going to be able to create a nice Boolean expression. There's that. So let's make these B, C, and D. And this is I minus 3, I minus 2, I minus 1, and I. So if A does not equal B, and B does not equal C, and A does not equal C, what is up with the formatting here? This is ugly. Okay, that's a little bit better. Okay, here, let's put the A's in front. So A does not equal C, and A does not equal D, and B does not equal C, and C does not equal D, and sorry, B does not equal D, and C does not equal D. System.out.println I. So this is found beginning at index. And I think we're gonna have an off by 1 error here, right? Because it's so if we look at this, this would be 0, 1, 2, 3. So it'd be at 4 that they were all different, but we need to return 5. So I plus 1. And then we need to break when this happens. And then we actually don't need to print anything right here. Okay, so that should be sufficient. Let's go ahead and run that. This is like a dumb way to do this, but fine. It's not the right answer. Okay, let's go back and look at our sample strings here. Okay, so let's give it a shot now. 61. Okay, so let's look and see what's let's take a look and debug, because this one should be relatively fast. So there. Let's take a look at input string. It's the full thing. Yeah. So MJQJ. So this should fail. Yep, because true. Whoa. Why did that? Okay, let's start that over. Stop and rerun. So B and D is false, so that's why it's failing. So now it's, yeah, but what is D? J, Q, J, P? This should be after the 7th character. Okay, so J, Q, J, P, no dice. Let's go forward. Q, J, P, Q, no dice. J, P, oh. This is probably what's wrong. Yeah, so now if we're here, and it's out, and it's printing out. Okay, cool. So let's try running this again. So now it should say 7 instead of 61. 7, thank you very much. So that means we were probably right on this, and we just outputted the thing -1 plus the character 1, 1647. Much better. Wow, what a terrible bug. Your device's communication system is correctly detecting packets, but still isn't working. It looks like it also needs to be looking for messages. A start of message marker is just like a start of packet marker, except it consists of 14 distinct characters rather than 4. Here are the first positions of the start of message markers for all of the above examples: 19, 23, 23, 29, 26. How many characters need to be processed before the first start of message marker is detected? So we're going to do a similar thing to what we do here. Like this part is all the same. But instead of doing this nonsense, we're going to say like for int j equals, it needs to be 14, I minus 13, j is less than or equal to I, plus j. We're going to make a set. Hash set. And there's probably a more efficient way to do this than putting it all in a set every time, but I think it'll be sufficient. Hash set character set equals new hash set. Thank you very much. Set dot add. And we want to add input stream dot char j. And then rather than this ridiculous conditional, we're just going to say if set dot size equals 14. Cool. So that should work. Let's just, well, that's just running part 1 again. Let's just run it again on part 2. String out of range index. Aha! That's because I now needs to start at 13. Fair enough. Oh, yes, we got it. Okay, that was very easy. So let's return to the advent calendar and let's look at our personal stats real quick. So 4,000th and then 4,000th. So unsurprising, we had a bug that took about 2 extra minutes. It's kind of a shame. I want these puzzles to be getting harder, but you can't complain too badly. If we go to our private leaderboards, yeah, Ryan hasn't even done yesterday's, which is kind of surprising. And on this one, yeah, Brian Kendall's right there. And I forgot to check this at the beginning. I was hoping to be able to see this to know what was going on. But it looks like so far the people that are doing them all are Kevin Chung, Puff, Nohei Dev, who shows up in Twitch from time to time, Brian Kendall, and myself. And so far I lead because I live on the West Coast and not all these folks do. It's as simple as that. Bly got in there, but he stopped. Same with Patrick. Kiana, Chris Thompson, and Brian Chen. Sometimes people do come back, though, and just do a bunch of this stuff, which is fair enough. All right. Well, let's go back through and clean up the code a little bit. Looking for characters. So start at the 4th character. Conditional if all of the characters are different. Wonderful. And for this one, I'm going to put the same couple of comments there. Looking for 14 characters, so do this. The set will only have size 14 if all of the characters are different. And in theory, perhaps we could do something better where we just remove an element from the set and then add an element back to the set or whatever, but then you gotta like deal with duplicates a little weird. So this is probably as fine a way as anything. This is still just a constant multiple times, and so it's still linear. So that's fine. That may not quite be true because of the set insertion, but hash sets are really fast, so that should probably be okay. Yeah, because sets are what, constant lookup and constant insertion. They just waste memory. Yeah, I don't want to do that. I want to. There we go. Cool. Excellent. So let me go through and explain. This is going to be a real short one. So, according to today's input, we're basically given really long strings. And for the first part, we need to know when 4 characters are all different. So we just pulled in the string. We started at the 4th character and said, grab that character and the 3 characters before it, which is what this is, and says, give me those 4 characters. Is A different than all of them? Is B different than the remaining ones? Is C different than the last one? Cool, you're done. That's it. And then you break and you've printed this stuff, and that's all you needed to do. For the second one, it's 14 characters, so the equivalent of this Boolean expression is very large. So instead, what we needed to do was we needed to make a set and then just add all the stuff to the set. So we add all the characters to the set, and then the set will dedupe any duplicate characters. So we can just see if the set size is 14 or not, and then we're done. In theory, you could do a little bit of stuff where you like are only trying to subtract the last element from the set, or you could use a hash map where you increment or decrement counts so that it's easier to see. Like that'd actually probably be fine if you went to a hash map and then you you inserted like the value of the count in there as you went. Then all you need to do is you need to decrement the count of 1 by deleting it. So if the count is 1, then delete it. And then insert the new one and then see if the size of that is 14. Because like the sum of the values in that hash map would be 14. That would be like marginally faster, but yeah, that would probably be a better solution if instead of 14 you're dealing with like 500,000 or something, because then my solution is obviously bad. But for only 14 characters, adding 14 characters to a set, n times is still linear. Like it's fine. Yeah, so that's it. Really simple problem today. That's pretty much all I got for you guys. So I'm going to go ahead and turn this into a YouTube video and set it to release at midnight. And I'll see you guys tomorrow. I can't believe that was so fast. In fact, I might catch the end of the Warriors game. Yeah. All right. Have a good night, everybody. See you in the next one.